Welcome to Open ELMS Podcast, turning your learning into a conversation.
I am so ready for this. Today's topic feels like a secret world not many people know about: thermal testing laboratories.
Exactly. It's this incredibly specialized field. At its heart, a thermal lab is all about one thing: evaluating how temperature and humidity affect products and their packaging.
So we're not just talking about a room with a big thermometer, right? This has to be high-tech.
Oh, absolutely. The bare minimum is an environmental chamber. Think of it as a super-powered, precision-controlled refrigerator or oven. And these aren't just little boxes. Some are massive walk-in rooms that can fit entire pallets of goods.
Wow, so you can simulate what? A trip through the Sahara Desert and then a flight over the Arctic in the same day.
You're not far off. They use advanced systems to maintain incredibly tight temperature tolerances, sometimes within a fraction of a degree. And the calibration of the sensors? It is absolutely vital. A tiny error can throw off the entire test.
I see. So once you have this amazing chamber, what do you actually do? Are all tests the same?
Great question. And no, not at all. There are two main paths you can go down. The first is general environmental testing.
Okay, what does that mean? Is that the Sahara to the Arctic test?
Got it. So it's flexible. What's the other path?
Standardized testing. This is where organizations like ISTA come in.
What's ISTA?
The International Safe Transit Association. They provide the rule book. They create specific standardized temperature profiles to evaluate packaging. Think of it as a universal benchmark.
So everyone tests against the same conditions to see if their packaging makes the grade. I like that. What's an example?
A perfect example is ISTA 7D. It offers specific temperature profiles for both winter and summer, for domestic and international shipping. The tests usually run for 24, 48, or even 72 hours to mimic real transit times.
Okay, so that's purely about temperature control. Does it check if the box gets, kicked or dropped?
Aha, you've hit on the most critical point. Standard profiles like 7D and 7E are focused on thermal performance only. They don't account for physical damage like shock or vibration.
That seems like a massive oversight. What good is a perfectly chilled box if it's been smashed to pieces?
You are 100% right. And that's why there's a Standard 20. This is the next level. It mandates a physical qualification of the container.
So you have to beat it up first, and then you test the temperature.
Essentially, yes. They perform shock testing, drop tests, incline impact tests to simulate the rough and tumble of a real shipping environment. Because think about it. If the container's structure is compromised, if that foam or a vacuum panel gets breached, its thermal performance is gone.
That makes so much sense. It's a holistic approach. It has to survive the journey to be able to do its job of keeping things cool. This must be the gold standard, especially for things like pharmaceuticals.
It is the gold standard. Which brings us to the labs themselves. You'd think there would be thousands of these places, right?
I would. With global shipping being what it is, for sure.
Get this. Globally, there are only 19 labs certified for the ISTA 7E protocol.
Only 19, that's surprisingly low.
Wait, it gets better. For the much more rigorous Standard 20, the one with the physical testing, there are only 11.
11? In the entire world? That's an incredibly exclusive club. It really highlights how difficult it must be to meet these standards.
It's a huge deal. And you know who a major player is? Christian Brothers University in Memphis, Tennessee.
A university? That's unexpected.
Not just any university. It is the only university in the world with an ISTA-certified thermal lab. It's the premier place for cold chain education. Students get hands-on experience with the exact protocols used by massive pharmaceutical companies.
That is so cool. So if I wanted to start my own lab and join this elite group of 11, how would I even begin? It sounds daunting.
It's a very structured path. First, you have to become a member of ISTA. Then you follow their Standard 14, which is the roadmap for certification. You also have to purchase Standard 20, which conveniently includes the 7E protocol.
Okay, membership, follow the standards. What else? Do you need special staff?
You bet. The lab must employ at least one certified thermal professional at level 2. Then there's paperwork, a pre-audit submission. And the final step, a successful on-site audit by an ISTA representative.
They come to you and check everything in person. The pressure must be immense. And I'm guessing it's not a one-and-done deal.
Not at all. You have to get recertified every 2 years to ensure you're maintaining those high standards. It's a continuous commitment to excellence and accuracy across the entire global cold chain.
Wow. From the basics of an environmental chamber to the intense, rigorous process of becoming one of only 11 labs in the world certified for Standard 20, it's a fascinating and absolutely critical industry. It really ensures our most sensitive goods arrive safely. Thank you for joining us on the Open ELMS podcast. We'll see you next time.
See you next time.